Dear students, good morning. As per last, we have seen the black and white TV transmitter in this lecture series of the communication electronics. So this is our second lecture. Today we are taking black and white TV receiver. So let us understand this topic, and you can contact me for your better queries understanding. So this black and white TV receiver, it starts with a folded dipole antenna, which is receiving the electromagnetic energy which has been already transmitted by using transmitter antenna. So this dipole antenna is used to receive the both that audio as well as the video signal will be received by using this kind of the dipole antenna. Now why this dipole antenna? You know that this dipole folded dipole antenna will provide the terminating impedance to the connected transmission line, which is equal to the characteristic impedance of the transmission line, and this impedance matching is always useful for better matching of the maximum transference of the received energy. Now both the audio as well as the video signal, it will undergo a super heterodyne action by using some kind of the circuit at the same time. So next slide, it is simplifying the detailed working of black and white TV receiver by using the block diagram. So first it is the antenna, that is the folded antenna, which receiving the energy, and then that energy is given to the radio frequency amplifier. Then this radio frequency amplifier, which is also containing the tuner circuit, it will give that energy to the mixer, and what mixer is doing, it is mixing that radio frequency with that of the local oscillator frequency to give the two intermediate frequencies, that is the sound intermediate frequency and the video intermediate frequency, which has been amplified by using that particular amplifiers. And then that audio signal are detected by using the audio FM discriminator. Then it is amplified and then given to the loudspeaker, whereas the video detector will detect the video signal, and which also contain the synchronizing pulses or the control pulses. They will be separated out, and the video signal which are detected will be amplified and then given to the picture tube of the television set or the receiver. And the synchronizing pulse separator will separate out the horizontal deflection, horizontal pulses, that synchronizing pulses, vertical and synchronizing pulses, as well as the other control pulses like blanking pulses and everything. So they will be given to the that yoke of the television by two different kind of the deflection circuit, that is the horizontal deflection circuit and the vertical deflection circuit. Now, to understand the construction and working, this electromagnetic energy which has been received by the antenna is given to the tune radio frequency amplifier, and it has a broad band pass characteristics. This stage help in achieving the good noise figure and providing the image rejection. The desired television channel is selected by tune circuit, and then the amplified radio frequency signal is then heterodyne in the mixer with a locally generated frequency using local oscillator. And what this use of the local oscillator here, this local frequency is mixed with the that received electromagnetic frequency to generate the intermediate frequency, which is nothing but a difference of the frequency of that difference between the electromagnetic frequency received and the local oscillator. And it will produce the two intermediate frequencies. One is the picture intermediate frequency, another one is the sound intermediate frequency. The frequencies of these two intermediate frequencies are standardized at 38.8 megahertz for picture and 33.4 megahertz for the sound. Now the outputs of the above stage are applied separately to the set of the intermediate frequency amplifier sections. One of the frequencies tuned to the sound intermediate frequency, and another circuit is tuned to the video intermediate frequency. The video intermediate frequency will provide a high gain of the order of 60 to 80 decibel to have the proper visualization of the picture on the television set. It provides the required bandwidth to amplify the picture and sound intermediate frequency to required extent. whatever the percent of the unwanted signal present in your video or the audio signal will be removed out by using the application of the rejection filter. Now image, how the picture is generated here. The image signal detector, which is also an amplitude modulation detector, the output of this will contain video signal and control pulses. This demodulated composite video signal is fed to a synchronization separator where the synchronizing pulses are segregated and get separated from the image signal. The image signal is directly applied to the picture tube then for displaying on the screen. The generation of the synchronization pulses are achieved by clipping out the 70% picture signal portion. You know that composite video signal contained 70 to 75% of the video signal and 25 to 27% of the synchronizing pulses. So they are separated out by using this clipper circuit. And these synchronizing pulses, when given to the integrator, it will produce the required vertical triggering pulses. And these triggering pulses are used for triggering the vertical oscillator, which generate the sawtooth vertical signal at the frequency rate of the 50 hertz. Now why 50 hertz? Because you know, as per the scanning process, in 1 second 50 times your electron beam is moving from bottom to top, and that the frame rate is also 50 per second. So that's what the here the frequency is set at the 50 hertz for the vertical synchronization. Same time the horizontal synchronization is also carried out. So when the synchronizing pulses are applied to the differentiating circuit, the horizontal triggering pulses are obtained, and these pulses trigger the sawtooth oscillator, which generate the sawtooth horizontal signal at the frequency of the 15,625 hertz. Now this rate also you are very well aware about why this frequency is set. It is also as per the horizontal scanning of the electron beam as well as the rate of the frame per second. These two kind of the synchronizing pulses then applied to the beam deflection circuit. There are two beam deflection circuit, that is horizontal and a vertical deflection circuit. So it will help us for keeping the scanning of the electron beam at the picture tube and at the camera tube in step with each other. So this is what the synchronization process takes place by using the synchronizing pulses. So this was about how the picture is generated on television set. Now for generation of the sound, 4 different sections are used. One is an audio intermediate frequency amplifier, second is the FM discriminator or a radio detector, third one is there are used one or more than one stages of the audio amplifiers, and last one is a loudspeaker. The sound signal generated from intermediate frequency amplifier are recovered by using FM discriminator, which after amplifying using the different audio amplifier stages are given to the loudspeaker, so that along with the picture signal, a picture or visual effect we are seeing on the screen of the television, we are also listening to the sound which is always in a step with each other. So student, this was about how we can learn about the different sections in the black and white TV receiver and how our black and white TV is working. I hope you would have understood this topic in a proper manner, and if you have still any query, you can contact me on my email ID through your Google Classroom login, and you can also WhatsApp me your queries on my WhatsApp number. So thank you very much for listening to the lecture.